The Subcommittee on Energy and Environment will come to order. Good afternoon. Welcome to today's hearing entitled Offshore Drilling Safety and Response Technologies. In front of you are packets containing the written testimony, biographies, and truth and testimony disclosures for today's witness panel. Before we get started, though, this being the first meeting of the Energy and Environment Subcommittee for the 112th Congress, I'd like to ask the Subcommittee's indulgence to introduce myself, welcome back returning members, and introduce any new members on our sides of the dais. Afterwards, I'll recognize Mr. Miller to do the same. It's an honor and pleasure for me to chair the Energy and Environment Subcommittee for this Congress, and it's a position I don't take lightly. I want all members of the subcommittee to know that I'll endeavor to serve all the members fairly and impartially, and that I'll work to serve the best interests of Congress and all Americans to ensure that the agencies and programs under our jurisdiction are worthy of the public's support. Although they're not here now, I'd like to formally welcome back our returning members Rohrabacher, Bartlett, Lucas, Biggert, Aiken, Naugebauer, and Brown. And I'd also like to welcome, when he arrives, our newest member, Chuck Fleischman of Tennessee. At this point, I'll recognize Mr. Miller for any if you want to introduce or just mention your members. Go on. Okay, thank you. I'll recognize myself for 5 minutes for an opening statement. The title of today's hearing is Offshore Drilling Safety and Response Technologies. The context under which we review the issue is framed by complex and interrelated environmental, economic, and even geopolitical policy concerns. Looming large, of course, is the Deepwater Horizon oil spill, of which we're still assessing its root causes and environmental impacts, even as we approach the one-year anniversary of the disaster. Meanwhile, American families are being hit hard at the gas pump due to multiple market factors, headlined, though, by tight supplies, rising global demand for oil, growing political instability in North Africa and the Middle East, and decreasing American production. The current national average price for a gallon of gas is over $3.60, the highest ever for this time of the year. This, of course, effectively amounts to a tax increase on our consumers and families and a drag on our economic recovery. Accordingly, I believe we must attack the energy problem from every angle we can. And expanding domestic oil and natural gas supply and production absolutely must be part of this equation. Offshore drilling holds incredible promise to help deliver on this goal. The federal government currently estimates the U.S. Outer Continental Shelf holds 85 billion barrels of technically recoverable oil at this point, over half of which is in the Gulf of Mexico, and 400 trillion cubic feet of natural gas. We must pursue exploration and production of these valuable resources. But we all realize, on both sides of the aisle, that we must do it safely and be prepared with effective well containment and response if and when an accident should occur. To this end, through this hearing, we aim to examine the status of safety-related drilling and response technologies and standards, with an emphasis on progress made since last year's accident. We also want to hear how best we should structure and prioritize federal programs in these areas, particularly those of the Department of Energy, but also interagency response efforts authorized by the Oil Pollution Act of 1990. Look, we all know it's impossible to completely and positively eliminate risks associated with complex endeavors such as deepwater drilling. But we must continuously work to reduce risks and to manage them in a way that allows our economy and American consumers to benefit from our vast supply of domestic offshore oil and gas resources. I yield back the balance of my time and now recognize Ranking Member Miller for his opening statement.
Thank you, Chairman Harris. And on this side, we also have very conscientious members, none of whom are here. We have seasoned members as well as members with expertise in the subject matter of this subcommittee. In addition to me, Eddie Bernice Johnson, the full committee ranking member. We have Ms. Woolsey, Ms. Lofgren, and Mr. McNerney, all Californians and well-known champions of a clean energy future. Mr. Lujan represents Los Alamos National Lab, brings his expertise on federal research and technology development to this subcommittee, and Mr. Tonko draws upon his experience as the CEO of the New York State Energy Research and Development Authority. Like you, Mr. Harris, we will take the jurisdiction of this committee very seriously, and we'll always look for ways to push our federal research agencies to be much more effective and efficient drivers of innovation and economic growth. Our job is to make sure the agency's capabilities is to know the agency's capability, know what the public needs, and create a credible and strong record on government's performance in meeting those needs. Where the energies succeed, we will support them, and where they fall short, we will take corrective measures, and ultimately we may decide to redirect resources, or we may support redirecting resources. Today, however, we are here to discuss the progress that industry has made in meeting the public's needs for safety and responsible oil and gas drilling. Just as we hold our agencies accountable, we must also hold industries accountable and expect them to acknowledge the tremendous risk, the tremendous danger inherent in the services they provide, the work they do. Before the explosion that killed 11 men sank the Deepwater Horizon drilling rig and generated the ensuing oil spill that lasted for nearly 3 months, offshore drilling was not at the center of public attention. As is often the case with energy matters, outside of the public policy world, the availability of oil was largely taken for granted, and the environmental risks were not widely known to the general public. All that changed on April 20th when we got a violent and lasting reminder of how dangerous our need for oil has become. As the world's largest oil consumer, but with less than 8% of technically recoverable global resources and far less than that of economically recoverable global reserves, our reliance on oil has driven domestic production to even deeper, ever deeper waters in search of more productive fields. Chairman Hall has taught us over the years, both as a Republican and as a Democrat, that this is no small feat of engineering. Those companies have pushed the boundaries of technological innovation in finding and extracting oil under nearly impossible conditions. But by almost all accounts, in the race to deeper waters, the industry's investment in advancing worker and environmental safety has not kept up with those increasingly dangerous conditions. To anyone that disputes that, I ask you to tell me how an explosion killed 11 men and sank one of the most technologically advanced drilling rigs in the world. Why did it take 3 months of failed attempts by a massive team of government and industry experts to stop the oil gushing from the disabled blowout preventer thousands of feet beneath the surface, creating one of the largest and most expensive environmental disasters in U.S. history? It was because nobody was prepared. President Obama has acknowledged that. He suspended new deepwater drilling permits in the Gulf until new safety measures could be drawn up and industry could give some assurance that they would be prepared if that should happen again. It would have been reckless not to do so. I imagine that we will hear today a good deal of misplaced blame. We will hear from some members, perhaps from a member, that the President is to blame for not being more diligent in overseeing the industry's drilling practices, that the President did not do enough to help the oil industry and gas industry develop new technologies, that the President was not quick enough or prepared enough to respond to the unthinkable disaster unfolding, and that the President's time out on the deepwater drilling has been a catastrophe for the industry. But from those members, or that member, we perhaps will not hear as much about the industry's culpability. We won't hear how the owner of Deepwater Horizon, Transocean, gave executive bonuses last year for their exemplary safety record. We won't hear how the most profitable industry in the history of the world did not see fit to invest resources in assuring that disasters like the Deepwater Horizon do not happen, or that it could not, or that it could be cleaned up if it did. Most important, we won't hear today the truth about oil and gas production under President Obama. We won't hear that the production actually continued in the Gulf during the temporary drilling suspension, that 39 shallow water permits were granted since October, that 8 new deep water permits have been granted in just the last month and a half. We won't hear that in 2010, outer continental shelf oil production increased by 30%, that domestic oil production is at its highest level in 10 years, and natural gas is at its highest ever. I do look forward to the witnesses' testimony today. I acknowledge the industry has made advances in safety in the last year, but it is not enough. We owe it to the public to hold this industry's feet to the fire and ensure that there is relentless innovation in worker safety and environmental protection in the oil and gas industry. Thank you, Chairman Harris.
Thank you very much, Mr. Miller. I know we're joined by the gentlelady from California, and if you would like to submit additional opening statements, your statement would be added to the record at this point, and if other members arrive, I'll make the same
That's
comment.
fine, Mr. Chairman.
Thank you. At this time, I'd like to introduce our witness panel. Dr. Victor Durr is Acting Assistant Secretary for Fossil Energy. Dr. Durr also serves as Principal Deputy Assistant Secretary for Fossil Energy, where he provides strategic direction and guidance for the program's daily activities as well as its long-term goals and objectives. Prior to that position, he was Deputy Assistant Secretary for Clean Coal. He holds a Ph.D. in Mechanical Engineering and has worked at DOE for 37 years. Mr. David Miller is the Director of the Standards Program for the American Petroleum Institute. He's also Chairman of the American National Standards Institute International Policy Committee and a member of the Offshore Technology Conference Board of Directors. He was elected a Fellow of the American Society of Civil Engineers in 2006. Mr. Owen Kratz is the President and Chief Executive Officer of Helix Energy Solutions Group, Incorporated. He joined CalDive International, now known as Helix, in 1984, and held various offshore positions before serving in a number of management positions before becoming CEO in April of 1997. And last, Dr. Macauley is Research Director and Senior Fellow at Resources for the Future. Dr. Macaulay's research emphasizes new technology and its application to natural and environmental resources. She serves on several national-level committees and panels, including the National Research Council's Space Studies Board, the NASA Earth Science Applications Advisory Committee, and NOAA's Climate Working Group. She has a Ph.D. in economics from Johns Hopkins University. I know that place. And also served there as an adjunct professor of economics. Now, as our witnesses should know, spoken testimony is limited to 5 minutes each, after which the members of the committee will have 5 minutes each to ask questions. Right up front, I apologize that we're starting late. We held a series of votes, and I'm going to apologize to you because your time is valuable. Now I'd like to recognize our first witness, Dr. Victor Durr, the Acting Assistant Secretary for Fossil Energy at the Department of Energy. Doctor.
Good afternoon, Chairman Harris, Ranking Member Miller, and members of the committee. As Acting Assistant Secretary for Fossil Energy, I appreciate the opportunity to present the Department of Energy's perspective on improving offshore drilling safety and response technologies. Before I delve into my statement, I want to take a moment to recognize and remember the 11 men that died almost a year ago while working on the Deep Horizon. As we approach the one-year anniversary of that tragedy in the Gulf, we know that there are important challenges we must meet in order to ensure that we never again see such a calamity on the human, ecological, and economic scales. Now, turning back to my statement, natural gas and crude oil provide more than 60% of our nation's primary energy needs. Last week, the President outlined a blueprint for a clean energy future. And to reduce our dependency on oil, we must develop and deploy new options like advanced biofuels, vehicle electrification, and improved vehicle efficiency. In the meantime, petroleum and natural gas will continue to play an important role in our economy for at least the next several decades. As both the Chairman and the President have said, we have domestic oil and gas resources here that we can use, and we will. In fact, last year, American oil production reached its highest level since 2003. But in the wake of last year's spill, the President has made it clear that we must tap into these resources safely and responsibly. As this committee knows, the Department of Interior is the agency with the regulatory authority over the oil and gas industry's offshore drilling activities. The Department of Energy, though can work with other federal agencies and industry partners to ensure that new technologies improve the ability to drill in ever deeper waters with greater margins of safety, reduce the risk of spills, and provide improved mitigation should a spill occur. To help meet rising demand, producers are looking to identify and tap new oil and natural gas sources, including many in areas that are increasingly difficult to locate and produce, such as deep water locations. Offshore oil now accounts for about 1/3 of our domestic field production, and 80% of this production comes from the Gulf of Mexico deep water sites. Deep water contribution to domestic oil and natural gas supplies is expected to increase in the years ahead. That contribution must be accompanied by ongoing technology solutions to production safety and environmental challenges, which will need to be developed and deployed. As the nation's largest funder of R&D in the physical sciences, DOE has long had a role in oil and gas technology development. Again, as I noted above, DOE has no regulatory role over the oil and gas industry, which is primarily the purview of the Bureau of Ocean Energy Management, Regulation, and Enforcement at the Department of Interior, as well as the National Oceanic or Atmospheric Administration and the Coast Guard. DOE's responsibilities regarding deep water research are outlined in Section 999 of the Energy Policy Act of 2005, which established the Ultra Deep Water and Unconventional Natural Gas and Other Petroleum Research Program. Until last year, DOE's activities under the deep water portion of Section 999 were focused primarily on exploration and production-related technologies, which we believe is more appropriately funded by industry. DOE has since refocused to work under Section 999 on safety and environmental protection associated with production. Consistent with budget requests since the fiscal year 2007, the President's fiscal year 2012 budget proposes repeal of the Ultra Deep and Unconventional Natural Gas and Other Petroleum Research Fund established as part of the Section 999A program. In the absence of this program, this important work can be carried out through investments from the private sector in coordination with the Ocean Energy Safety Advisory Committee. In the wake of the Deepwater Horizon accident, industry developed new technologies to contain underwater blowouts. However, additional work remains to ensure that deepwater resource development is safe and environmentally sound. The administration believes that it is appropriate for industry to assume the funding of these activities, and DOE stands ready to provide technical expertise and assistance through both the Office of Fossil Energy and our participation on the advisory committee in order to integrate enhanced safety and environmental capabilities into deepwater production technologies. In conclusion, Mr. Chairman, deepwater oil and gas will be crucial to meeting the demand as we continue the transition to a more sustainable energy future. At the same time, last year's tragic oil spill serves as a stark reminder of the risk associated with deepwater drilling. As improved extraction technologies are developed and implemented, so too must be approaches for addressing potential risks, safety issues, and environmental impacts. With that, Mr. Chairman, I respectfully request that my written statement be included in the official record of these proceedings, and I would be happy to answer any questions that you and the other members of the committee may have. Thank you.
Thank you very much, Dr. Durr. And now I recognize our second witness, Dr. David Miller, the Director of Standards at the American Petroleum Institute. Mr. Miller.
Good afternoon, Chairman Harris, Ranking Member Miller, and members of the subcommittee. Thank you for the opportunity to address offshore drilling safety and response technology. My name is David Miller. I am the Standards Director for the American Petroleum Institute, or API. API has more than 470 member companies that represent all sectors of America's oil and natural gas industry. Our industry supports 9.2 million American jobs, including 170,000 in the Gulf of Mexico related to the offshore development business, and provides most of the energy America needs. First, even though it's almost been a year since the tragic accident in the Gulf, it is important that we remember the families who lost loved ones, the workers who were injured, and all of our neighbors in the Gulf who were affected by it. Their losses were profound, and they remind us every single day that the work we do to improve safety in our operations is extremely important. Our industry's top priority is to provide energy in a safe, technologically sound, and environmentally responsible manner. We therefore take seriously our responsibility to work in cooperation with government to develop practices and equipment that improve operational and regulatory processes across the board. As further proof of our commitment, API has been the leader for nearly 9 decades in developing voluntary industry standards that promote reliability and safety through proven engineering practices. API Standard Program is accredited by the American National Standards Institute, ANSI, the authority on U.S. standards, and the same organization that accredits programs at several national laboratories. API standards are developed through a collaborative effort with industry experts, as well as the best and brightest technical experts from government, academia, and other stakeholders. API Standards Program undergoes regular third-party program audits. API maintains more than 600 standards that cover all aspects of the industry, including 270 focused on exploration and production. The committees that develop and maintain these standards represent API's largest program, with 4,800 volunteers working on 380 committees and task groups. API standards are frequently referenced in federal regulations because they are recognized to be industry best practices. Overall, nearly 100 API standards are referenced in more than 270 citations by government agencies, including the U.S. EPA, the Department of Transportation, OSHA, and in addition, 80 standards referenced by BOMR. And as part of our commitment to program transparency, last year API made the decision to provide all of our safety and incorporated by reference standards available for free online. We are using the incident investigation findings to continue to improve the technologies and practices to achieve safe and environmentally sound operations. As part of this process, we are working to develop new API standards and revisions of existing API standards where necessary to raise the bar of performance to a higher level. We have already published a new standard on isolating potential flow zones during well construction, which has been incorporated by BOMR into its offshore regulations. We plan to complete work later this year on 2 new API standards, one on deepwater well design and one on well construction interface. We are working also to update the API standards on blowout preventer design, manufacture, and operations. In addition, API's Board of Directors just last month approved the formation of the Center for Offshore Safety with the mission to promote the highest level of safety for offshore operations through an effective program that addresses management practices, communication, and teamwork. This program's foundation will be API's recommended practice on safety and environmental management programs, the API standard most recently cited by BOMR. Regarding permitting delays, the recently lifted moratorium and subsequent safety regulations led to some confusion and concern in the industry. For example, the interim final drilling safety rule, published in October of last year, contained text that summarily changed all 14,000 should statements to must requirements in the 80 referenced API standards. And while DOI did provide a clarification, it wasn't until just last week. In the meantime, industry felt it had no choice but to consider how it could possibly be in compliance with the requirements that were often contradictory and potentially unsafe. This uncertainty has added unnecessary delay in developing exploration and production plans and applications for permits to drill, as industry was forced to consider the requirement to request up to 14,000 departures simply to be in compliance with the standards that its and the government's technical experts had developed. In fact, API provided extensive comments to DOI as part of its White House mandated regulatory review. One item of significant import is compliance with the Outer Continental Shelf Lands Act amendments of 1978, in which Congress declared that the Outer Continental Shelf is a vital national resource reserve held by the federal government for the public, which should be made available for expeditious and orderly development, subject to environmental safeguards in a manner which is consistent with the maintenance of competition and other national needs. By statute, the leasee is entitled to a timely and fair consideration of submitted plan and permit requests, and exploration plans and application permits for drill must be acted upon within 30 days of submittal. DOI should work to meet this statutory requirement. Permitting delays in the moratorium have already led to the loss of 300,000 barrels a day in oil production since May of 2010, according to EIA's short-term energy outlook, and the jobs loss is no less disturbing. Dr. Joseph Mason of Louisiana State University, which recently testified before the House Subcommittee on Energy and Power, noted in a follow-up interview that we have already, however, pushing above the administration's estimate of 20,000 jobs nationally for the deepwater de facto and de jure moratoria. We look forward to providing constructive input as this committee, the Congress, and the administration consider changes to existing policy. Industry is ready to return to work, Mr. Chairman and Ranking Member, and seeks clarity and certainty in the permitting process. This concludes my statement. I welcome any questions from you and your colleagues. Thank you.
Thank you very much, Mr. Miller. Now I'd like to recognize our next witness, Mr. Owen Kratz, the President and CEO of Helix Energy Solutions Group.
Mr. Chairman, members of the subcommittee, thank you for the invitation to testify today. As the head of a team called upon to respond to the Macondo incident, I believe Helix Energy Solutions experience can be of assistance to the subcommittee as it evaluates response policy going forward. 3 Helix vessels, the Q4000, the Express, and the Helix Producer 1, were instrumental in successfully bringing the deepwater blowout under control. At the Macondo site, Helix staff logged a total of 135 days aboard the Q4000 alone. The lessons we learned will inform our approach to containment efforts well into the future. In December 2010, Helix brought numerous independent operators together to form the Helix Well Containment Group. Our purpose was to develop a comprehensive, rapid, and effective response to a deepwater well control incident in the Gulf of Mexico. Currently, 23 leading energy companies belong to the consortium, Working in close collaboration with BOEM RE, we designed a comprehensive 1,000-page well containment plan that meets the agency's requirements in NTL-10. The plan addresses multiple scenarios inclusive of specific well information and deployment procedures, many of which were refined during the Macondo response effort. Technical experts and critical equipment from each of the 23 member companies will be made available to any member during an event, providing a fully compliant level of capability as required by NTL-10. The system is specifically designed for expansion and inclusion of developing new technologies. The Helix fast response system is ready to respond today. In fact, 5 drilling permits have recently been granted based on our containment system. What does it mean to be prepared for an endeavor as complex and time-sensitive as an undersea well control incident? The Helix Fast Response System's interim containment system includes a 10,000 pound per square inch capping stack, a riser system, the Q4000 intervention vessel, and all necessary equipment to complete the intervention system. This system is capable of completely capping and closing in a well that has the necessary mechanical integrity to do so, or allowing flowback and flaring of up to 55,000 barrels of oil a day or 70,000 barrels of liquids per day, and 95 million cubic feet of natural gas per day in water depths up to 6,500 feet. This system, as described there, stands ready today. The next stage of readiness, which we refer to as the complete containment system, is designed to handle more comprehensive responses by including a 15,000 pound per square inch capping stack and a riser system capable of operating in 8,000 feet of water. By April 11th, our system will be capable of completely capping and closing in a well that has the necessary mechanical integrity to do so, or allow flowback by a combination of producing and flaring. By April 15th, the 15,000 pound per square inch capping stack will be available. Next slide, please. Finally, as we look into the future, we're evaluating an even further expanded system having capability to 10,000 feet of water that will allow capture and flowback of up to 105,000 barrels of oil per day and 300 million cubic feet of natural gas per day. Approval of this expansion will take place only if the members of our consortium decide a system with this capacity is necessary. If they do this, then the vessel or the system could be ready by 2012. One of the most innovative parts of the U.S. energy industry comes from a robust and healthy offshore independent oil and gas sector. A diversity of upstream players has produced countless innovations, and they're not always the largest companies. Yet one of the major impediments faced in convincing the producers to dedicate the means to provide a solution in a more timely manner is the uncertainty surrounding the government's policy as to what specifically will be accepted as a sufficient containment solution. Helix is grateful to the BOEM RE for the relationship that we've developed. Government can greatly aid the process by continuing, if not hastening, to resolve uncertainties inherent in early drafting of the regulations and to address concerns of the industry as to what may be deemed deficient in the process of drilling that may arise in the future, such as liability caps, lease expirations, and spill response. Additionally, the government could play a productive role by assisting in minimizing the cost of capital through reinvigorating programs designed to advance maritime industrial development. The loan guarantee program administered by MARAD, for example, can help. It has a proven track record. In fact, the Q4000 was built in Texas using the MARAD financing. Thank you for the opportunity to testify today. The industry's always developed innovative technologies and processes, even in the face of the toughest challenges. Now, with the experience of Macondo behind us, we've learned how to fashion an even more appropriate, effective containment system. Thank you.
And thank you, Mr. Kratz. I now recognize our final witness, Dr. Molly Macauley, Research Director and Senior Fellow, Resources for the Future. Dr. Macauley.
Good afternoon, Chairman Harris. Good afternoon, Chairman Harris and Ranking Member Miller, subcommittee members, and panelists. I'm an economist and research director at Resources for the Future, which is an economics research organization established by the President of the United States in 1952. And my comments today draw from work that I carried out together with colleagues at Resources for the Future. And we undertook this work for the National Commission on the BP Deepwater Horizon oil spill and offshore drilling. But my comments today are my own. They do not represent the views of the Commission nor of Resources for the Future. As an economist, I know that jobs matter not only in the Gulf, but to this nation. I appreciate the role of energy. It is our nation's lifeblood. I'm aware of the concern expressed by businesses of all stripes, government and the public, about the need to balance the benefits of energy with the risks in producing energy of all types, both fossil and renewable. The public cares. We mourn when we lose coal miners, oil riggers, nuclear plant operators, and when the environment is harmed. I think people want government and industry to balance that risk. And in fact, the nation mourned the loss of those on the rig. And then, in addition, perhaps the most disturbing result of the Deepwater Horizon spill a year ago was not that the spill could happen. Small spills happen all the time, but that the spill could not be promptly contained. And containment is precisely what I've been asked to speak about today. So I'll make 2 points. The first about containment in the near term over the next horizon for spills similar to last year's, roughly in about 5,000 or so feet of water, and this speaks to the technology that my panel colleague has just described. And then the other point I'll make is something near and dear, I think, to this subcommittee's reason for being, which is research and development for containment in the future. And this is particularly in the case of ultra-deep water. You know, these depths are greater than 5,000 feet, and it's a very extreme environment in which to operate. Pressure, temperature, geology, it's very similar in its extremities to what we do with our nation's space program. It's an extreme environment. It's very unique in that regard. And the genius of industry is that it's drilling there. It is drilling successfully in ultra-deep water, much like we're very successful in the extreme environments of space. According to the Energy Information Administration, production in ultra-deep water is really where the action is. Production at these depths has risen sharply. In fact, according to the EIA, production there has reversed the decline in overall Gulf of Mexico production that began in 2003. So, containment in the near term. As we've heard from Helix, industry has stepped up and committed over $1 billion to supply containment services for some types of spills in the Gulf of Mexico. Helix played a major role in helping to contain the deep water spill, and the newly formed Marine Well Containment Corporation, MWCC, is also part of this industry effort. I understand there are some types of spills for which these services are not optimized at the present time, but the adequacy of containment readiness is being jointly determined, not only what industry is willing to supply, but what government is demanding. It's a joint effort here. I think where I lose sleep is on my second point. It's not so much containment today, because there are very strong incentives for government and industry to make sure containment works. Imagine the public reaction to another large spill anytime soon. But where I lose sleep is about the next battle. Again, these ultra-deep water depths exceed those where MWCC and Helix are prepared to service at the present time, although, as Helix mentioned, if your members agree, you may be prepared to go up to 10,000 feet. And that is exactly my point. In the event of a spill at these deeper depths, will we have to innovate on the fly again? What new science and engineering and state-of-the-art risk assessment do we need now? Who has this game plan? In short, are we innovating such that the capacity to contain keeps pace with capacity to drill in increasingly extreme environments? Now, the National Commission acknowledged these questions. It did not consider them at length, and if unanswered, these questions point to a potentially large gap in our public policy. And there is a reason to ask these questions. As a nation, our industry and our government tends to underinvest in R&D for a lot of reasons. It takes money to do R&D. Sometimes the results aren't fully appropriable. The reward is shared widely, and it doesn't return to the innovator. And the problem of innovation in containment is particularly difficult because government limits liability for a spill, and regulation is sometimes not as effective as we would like it to be. These blunt incentives to contain and incentives to innovate. And if we discover new ways to contain, we want that technology widely deployed, yet proprietary innovation is not always widely deployed. I note that the Commission staff paper points out that within a few years after the Valdez oil spill, efforts to innovate in spill response had dwindled to almost nothing. So I have 3 suggestions for what the committee or other policymakers might do. First, have some discussions, not only with Helix, but with MWCC and others supplying containment services. Ask them what their plans are for innovation. Second, already a panelist has referenced the new permanent federal advisory group on safety, containment, and response. Federal advisory groups can do a good job, but who is going to listen? Who is going to act upon their suggestions? And third, and this is more substantial, disadvantages and advantages worth talking about, but we might consider changing the liability regime to risk-based drilling fees, much like risk-based insurance premiums, risk-based liability caps for each well, or phasing in requirements for insurance to cover damages to third parties. So I think a prudent approach, and the best we can do is make sure we align incentives to think about the R&D for the next battle. It still may have to occur, but at least we will have done the in-advance, long lead kinds of research and development that will be necessary then. Thanks very much for asking me to join the panel today.
Thank you very much, Dr. Macauley, and thanks to all the panel members for their testimony. Reminding members of the committee rules limit questioning to 5 minutes, and the chair at this point will open the round of questions, and I'll recognize myself for the first 5 minutes. Dr. Durr, thank you very, very much for coming and testifying before the committee. My understanding from your testimony is that once again the President's budget proposes repeal of the ultra-deepwater and unconventional natural gas and other petroleum research fund. And I've got to ask that given the fact that we are recently, it's coming to our attention that our oil reserves, our recoverable reserves, both for oil and especially now for natural gas, is coming to be realized, that we have these reserves. Why don't you think there's a role for the government in trying to figure out how to get to them safely? Not just the safety, but how to, partnering with industry or, in fact, doing some of the research. My understanding that, for instance, the research to get to our shale natural gas, is one fellow who thought, yeah, this could be done when everybody else said, no, it couldn't be done. But he did. It took him years and years to figure it out, with apparently little help from the government, even though we sit on these resources. So, Doctor, why is it not appropriate for the government to actually help, as part of this program, to do some of that innovative research that could get to more of our oil and natural gas, given the rising price of energy, the rising cost of gas?
Thank you for that question here. I want to let you know that this innovative person who developed and commercialized the technology for hydrofracking and horizontal drilling was in fact a result of the early research that the Department of Energy had engaged in. We had spent, I think, on the order of something like $137 million between the 1980s and 1990s that released trillions and trillions of potential in terms of natural gas in this country. So the role of the government early on is there, but oil and gas production is a fairly mature technology, and the industry, in the administration's opinion, is that they are well capable of investing in these types of technologies to unlock and unleash these domestic potential resources that we have in our country. Continuing forward, I think that we do have a role in helping advise and assist where necessary in terms of safe and responsible drilling in areas such as the ultra-deep regime. But again, the administration's position is that the oil companies and gas companies, the majors, are very well equipped to make these types of investments on their own with the guidance from groups such as this advisory committee I spoke of in my opening statement.
Yeah, thank you. I guess the only follow-up I'd say is if you think that those $137 million, which we invested in the past, had something to do with leading to the development of the new technology to unlock some of the natural gas, it almost makes an argument for continuing for the government to do things like that, because that has yielded some result. Mr. Miller, let me ask you a question, because it appears that we're going to be buying oil that is found in deep waters off Brazil. That there's a national decision has been made to invest billions of dollars through the Export-Import Bank to do deep water drilling off Brazil. So I've got to ask you, what are the standards that they're going to have? I mean, because the API is developing all these standards. First, is there an international equivalent of the API? Are they ahead of us or behind us on these standards? I mean, it begs the question: how do we make certain that when we're supporting this drilling elsewhere in the world, how do we know that it's going to be up to the standards that we hope to have here in the United States?
Thank you for the question. There are really a couple of ways to answer that, Chairman. The first way is that API, as was mentioned when you gave my bio, is very involved in international standards development. And I'm the chairman of the ANSI International Policy Committee, and one of the things we look at is how industries work with the International Organization for Standardization, or ISO, which is based in Geneva and develops standards that are worldwide recognized. And in our support of that particular set of committees that develop international oil and natural gas standards, approximately 70% of the standards that they've developed under that one committee are base API standards. So number one, we've worked with our international counterparts to make sure that these best practices are moved around the world and used around the world. The second point I would make is that in a study that was done last year by the UK-based Oil and Gas Producers Association, looking at 14 different producing regions around the world, they found that API standards were the most widely referenced by the regulators, with over 225 citations in addition to the citations here in the United States. So the regulatory regime is there for both the standards to have been transferred and used through the ISO process, or the International Organization for Standards process, in addition to the regulators using the API standards for their regulations as well.
So in Brazil, if they're going to drill using those standards, then your feeling would be that we should be, since those standards roughly are going to be equivalent to the standards we have here, then perhaps we should be doing it here as well. I take it that you think they're roughly equivalent.
Absolutely, and I would think that with the strong records we have here, we should be expanding our drilling operations here in the States.
Thank you very much. And now recognize Mr. Miller.
Thank you, Mr. Chairman. Just as a layman, when I hear that there is a device called a blowout preventer on a well, and the well has a blowout, my conclusion is that the blowout preventer probably didn't work. Mr. Miller, is there a flaw in that reasoning?
I remember to do that. I'm sorry, to answer your question, I know that there has been a study that has just been released that has come out that is looking at some of the potential problems that occurred in the Deepwater Horizon. We've got a group of technical experts that are looking at the standards that cover blowout preventer design and operation, and in addition to other items that we were already looking at, we're looking at that case where you did have that uncontrolled kick, if you will, that according to the study, and we haven't fully had a chance to digest it yet because it's over 500 pages, where they theorized that the kick and the uncontrolled release pushed the pipe into a place where the shear ramps did not fully close. So we're looking at those design requirements to make sure that as we update the standard, we consider those results.
Well, some scientists or some engineers who have looked at this have said that the assumption that the pipe would be centered at that depth with those pressures from every direction, those pressures were not unusual. I mean, they're usually unusual. And some engineers have said that if it was actually centered, it would be just dumb luck. It would be like a clock being, a stop clock being correct. It does happen twice a day, but it's really just dumb luck. What are the differences between drilling and, or the safety considerations, the technological challenges in safety and environmental protection between shallow water and deep water drilling?
Well, I'm not a drilling expert, but I can talk a little bit about the equipment itself. It's governed by 12 separate regulations under BOMER. In each one of your BOPs, you're required to have at least one annular ram, which is sort of the rubber donut that sits on top, 2 pipe rams, which do help you center the pipe and also can help you close in a blowout, and then finally a blind shear ram that closes that. One of the other things that we're looking at is that we understand, and this was just announced I think earlier in this week, that we'll be seeing additional proposed regulations from BOMER. We understand there'll be an advance notice of proposed rulemaking on BOP design, manufacture, and operations. So we'll have a chance to take a look at what they're believing we need to be looking at as far as our design requirements, those particular pieces of equipment.
Mm-hmm. What role, if any, well, if you really are not claiming any expertise in drilling or drilling safety?
No, my expertise is in standards and standards development and the technical standards that support drilling operations and equipment, but not as a petroleum engineer, drilling engineer.
Okay. Well,
Would you mind if I added something to that?
Yes, sir.
I think it's important when you're in any discussion, and I'm not an expert on BOPs, but if any discussion about BOPs, I think it's important to understand that any technology has operational limits. And I'm not making a comment on Macondo or not, but the BOP is actually the last barrier of defense in a series of barriers used to control a drilling operation. So when you say the BOP failed, what has to occur for that to happen is several other systems have to fail as well. And I think what Macondo has taught us is that no matter how well the system is designed, and I think the government, the BOM, has it right on this, you can't rely totally on prevention. And that's where the missing link of the next step of containment comes in, is for the inevitable.
Okay. Well, let me search for a witness who seems to have expertise on a topic I want to ask about. Dr. Macauley, you were an economist, PhD, and you mentioned liability. And liability caps and the effect that had on innovation in the safety area. I don't claim to be an economist, but I've studied kind of the economics of liability, the theory behind legal liability, and that potential liability is kind of the economic incentive to safety practices. What is the economic effect of setting a cap, a liability cap on safety innovation?
Yeah. It's an excellent question because it's so relevant to what we're discussing. A liability caps what industry will be liable for, and who puts the bill in? The other parties, the taxpayers in this case. Liability caps serve important purposes. They're often thought to allow small companies to enter in, and you don't have to bet the company in order to provide a useful public service, in this case offshore drilling. On the other hand, the very fact that you have a cap does say, well, who will pay? Taxpayers, but we have this trade-off. We're allowing small companies to participate, provide that competition. So setting the liability cap is really important. To the extent it can be related to the risk, then you begin to put incentives in place to bring about the very prevention, containment, and effective response that we're talking about, though.
Well, will the liability, will the safety efforts match the potential liability if there's a liability cap?
I think that industry has an incentive to pay attention to the liability cap to protect its shareholders. Industry also has a reputation to uphold, though. So it may well be that industry acts beyond the cap because reputation really matters. What the public thinks is very critically important, as we know in the case of nuclear power plant safety. So the role of the liability cap is a complex one.
All right, Mr. Chairman, I see my time has expired. There are three documents, studies of this blowout, this disaster that I would like to enter into the record. The first is the study, and in each case, I've accepted out the portions that seem to be pertinent. If the chair wants to add additional chapters, that's fine, but these seem to be the ones pertinent. The first is a report by the Det Norsk Veritas on their forensics examination of Deepwater Horizon's blowout preventer that they undertook for the Department of Interior. DNV concluded that the buckled drill pipe inside the blowout preventer obstructed the blind shear rams that the witnesses just described, and their ability to shear the pipe fully and seal the well. And in addition to the introduction, Chapter 4 would be sufficient to deal with those conclusions. And then two other documents from the Department of Interior. One is investigation MMS report 2001-009 and report 2004, page 21, conclusion 6, and before that, page 5. Those appear to indicate that BOP failure similar to that depicted in the DNV report had occurred in the past decade on two other occasions. And, Mr. Chairman, I would now move these three documents into the record.
Thank you very much. I thank the ranking member for sharing that with staff, and without objection, so ordered. With respect to the DNV report on the blowout preventer, I think it's worth noting for the record there appears to remain a great deal of uncertainty surrounding what actually did happen at that day and the conclusions reached in the report itself. So to that end, I'd like to enter into the record an article from the New Orleans Time-Picayune that summarizes some of the issues in question, in particular the accuracy of DNV's computer modeling that they used in their report of the blowout preventer. And so thank you.
Is that the article that really talks about the lawyers' questioning of the? Okay, well, I certainly welcome the chairman treating lawyers as expert on all topics on which they represent a client.
That may be unusual for this physician, but anyway, Ms. Woolsey, if you're recognized.
Thank you, Mr. Chairman. Mr. Chairman, for as complicated as this topic is, I feel like my questions are really basic, but I think they're necessary. So Mr. Kratz, when you were talking about Helix fast response system being ready and up and ready to go now, how long did that take to develop, and what if we'd had it in place before the Deepwater Horizon oil spill? How much difference would there have been in the results, and why weren't we doing this sooner?
I think it's important to note that Helix is a well intervention company, which is different from a well service company like a Schlumberger or Halliburton. They're the ones that actually do the work down inside the well. Helix's expertise is actually getting onto a well and into a well. What we do every day with our vessels is intervene into live oil wells. And then allow the service companies to do the work. So getting into the well is not new technology. In fact, the capping stack that we have, we actually fabricated 2 years prior to Macondo. So the technology is there. We do it every day. It's reliable. The issue really is on readiness and preparedness, because it is a complicated operation and it takes an awful lot of people to be coordinated. And that's where the consortium has spent a lot of their time on preparing these procedures, and we've actually run 2 tabletop drills now just to refine it, where you're actually simulating a crisis and trying to refine it.
Let me just interrupt a minute.
Sure.
That's why we care about this in this testimony on this subject today. So why didn't we have all that tabletop exercise done before this all happened? I mean, were people just taking it for granted?
It's a good question. I think the industry's predominant view was on prevention, and probably an over-reliance on prevention. And I think that following Open Night or the Valdez incident, there was a lot of focus on spill cleanup. The part that there was supposed to be a renewal but as the industry went deeper, the missing link, between the inevitable spill and the cleanup was sort of overlooked. Right. And the innovation of our equipment for application onto the blowout actually came from the fact that innovation occurs through the commercial incentive of the well intervention market. It just happens that the same technology is very easily applied to blowout containment.
Okay, and with the idea that April 11th, the new system will be up and ready to go, feels a little bit like what company's coming. I'm going to be a witness. We better hustle and get this done. But whatever the incentive was, it's good that you have that new technology developed, or system developed.
We're actually late.
Well,
we had promised it over a month ago, so we're behind schedule.
Well, get on with it. Dr. Durr, last year, this committee and the full House passed my legislation, the Oil Pollution R&D Program Reauthorization Act, which would have doubled the federal investment in oil spill response technologies. Unfortunately, the bill was not taken up by the Senate. But my question to you is, in your opinion, would doubling, currently, do we have enough federal investment, or would it have been better to pass this and double the investment in oil spill technologies? How much do we need, and who should contribute?
Well, as I mentioned before, and I think our Secretary has testified, that the funding of oil and gas research relating to safety and environmental mitigation should be the responsibility of the industry, since they are a very big industry. They can afford to do that kind of work. Our role in the Department of Energy here would be to help guide some of that activity, but I think in the end it should be funded by industry. Our ongoing work in the Section 999 has refocused the emphasis on safety and response and environmental aspects and sustainability.
So your current budget in order to do this oversight that you and encouragement, is it enough, or would you prefer that we increase it?
Well, primarily I would have to say that the response on oil spill is primarily the responsibility of the U.S. Coast Guard and those programs that should come under its purview. But the Department of Energy does have a lot of technical expertise that could help in that regard.
That's right. And the Department of Energy is part of the team of the Coast Guard and NOAA to keep these systems and these programs current. I mean, we were way back in another century virtually when we came forward for this deep water protection and know-how. So, okay, I just wanted to make sure you knew that we were trying to get you more.
I appreciate it. Thank you.
Thank you, and I'm going to take the opportunity to ask a few more questions and give the opportunity to any member here to continue questioning at this point. Mr. Kratz, let me ask you a question with regards to recap part of your testimony. Obviously, from your testimony, had that accident occurred after April 15th, when this 15,000 pound per square inch cap would be available, your opinion would be that it could have been contained.
Our current cap, the 10,000 pound cap, could have contained the well.
Well, but I thought the testimony was that the measured pressure was 11,800 or something. It's in your.
Yeah, shut-in pressure though was within.
Okay, so that could even be done by the system you have now. So let me ask you, where does that stand? That kind of pressure, where does that stand within the range of what is? And I got to ask, are pressures always measured? Are these estimated pressures? What are they?
The shut-in pressure?
Yeah.
That would be read off of a gauge.
So it's a measured pressure. So what's the range of measured pressures that you have? As we gauge whether or not your systems would be adequate to reasonably, to prevent the vast, virtually 99.9% of these kind of problems, what's the range of pressures that are measured?
A majority of the systems internationally, and you might comment on it, but are rated at 10,000 psi. It's only more recently that 15,000 psi pressures have been encountered, and you're seeing a greater and greater proliferation of it. But still, 15,000 psi is relatively rare.
That would be rare. And let me ask you: does your company also do bioremediation, or is that the idea of developing something that eventually, if some oil spills, some bacteria or some organism actually just consumes it?
No.
And when the oil's gone, it's died. Who does that?
I believe that would come more under the purview of spill cleanup kind of a company, which we're not involved. Well,
Dr. Durr, let me ask you: has your shop done any of this? I mean, that would come right under the purview of environmental protections against spills, and that's a kind of biological development that may fall in the cracks. I mean, I don't think the NIH is doing it. Mr. Kratz is not going to do it. Who would be doing that? I mean, how are we developing those alternative, those thinking outside the box techniques?
Well, again, the response capability in spill response is the U.S. Coast Guard's. But I think there are technologies that we've been working on in the laboratories that may have some bearing on that. Again, our role is to help assist and to advise through our program with through the Safety Advisory Committee.
But is it funded through this program? I mean, because the recommendation was to eliminate this program, and my only response is, as I think Dr. Macauley mentioned, there are some things that probably you might need, government research support in order to develop some things to make these types of endeavors, these exploration and production endeavors, safe.
The program that we have currently under the Section 999 was refocused from the efficiency and economics of production into safety and environmental aspects. And I'm not 100% clear that we have that funding under Section 999.
But why not? I mean, why wouldn't you do? Why would you want to zero out a program when there are questions that, really, some basic questions that could be answered, that could result in fact, even safer production and exploration?
Well,
I guess I'm asking why should we get rid? Are we really sure there's no role for some basic research to be done to make these techniques of production and exploration safe and environmentally sound?
I think there is, but my point is that the funding of those types of technologies should come from industry, and they can make use of the resources that we at the Department of Energy and our national labs have.
So that would be in contradistinction to, for instance, how we handle medical research, where we could say, look, medical device companies, hospitals, they all make a lot of money, but yet we think there's a role for some basic research in other areas of the government. So you think we should just think about this completely differently?
I'm not familiar with the medical field, sir.
Well, we spend tens of billions of dollars on research that one could make the argument that some pharmaceutical company should fund, some medical device company should fund, someone who's going to make money on the final product should fund it. So I just ask that you consider that it's my opinion that there may be areas like that. And Dr. Macauley, I was going to just ask you, because you mentioned that perhaps there may be some areas. I mean, what kinds of new science do you think it might be under the purview of the federal government to be involved in? Basic materials, bioremediation. What do you think?
Yeah, I think this discussion of what is the basic research is an interesting one. My colleagues and I, when we were working on our research project, we were searching to find a discussion of the R&D that would be needed to see how much of it is basic, how much of it is development, how much is it ready to prototype. This is why I think there's a policy gap at the moment. I'm not sure we have a full understanding, and if it is really, really basic research, it could be exactly what we need for, the STEM concerns, the science, technology, et cetera. So I would love to see that intersection, but we weren't able to find anything, any information
that's being done. Well, thank you very much. Mr. Miller?
Thank you, Mr. Chairman. I think when the chairman and I agree, we should pause and celebrate that, as we did when he earlier agreed to the expertise of lawyers on almost any topic. But I'm very pleased to hear him supporting research. But we saw in H.R. 1 dramatic cuts in research funding, and even in this committee just a couple, 3 weeks ago, cuts to the FAA's authorization bill for research into safety, flight safety, icing, human error, cockpit fires, and smoke. And the argument for cutting that funding was that was applied as opposed to basic research, and applied research should be paid for by the industry, not by the government. It certainly appears that this industry, the oil and gas industry, is vastly more profitable than the airline industry. And I know that there's not a bell that sounds when basic research crosses over into applied research, but is correcting the flaws in a blowout preventer or containment technologies basic or applied research? Anyone? Dr. Macauley? And do you agree with that distinction, and that we shouldn't fund applied research?
I never argue for government intervention unless it seems to really be necessary. The comment that industry will do the innovation on its own, sometimes industry does, sometimes industry doesn't, and it's identifying, is there a market failure in R&D to ensure the health of our offshore deepwater drilling industry? That is a gap in our understanding as policymakers at the moment. And I do hope that we can get a better handle on where those gaps are and what is the nature of the R&D and who is doing it.
Okay. Well, Dr. Macauley, you said that there was more than just the economic consideration of liability. There's reputation at stake. But I've seen folks who've made a whole lot of money doing really disreputable things be accepted into polite society, and their acceptance seems to have been greased by how much money they had. Now, I know that Tony Hayward, it appeared to hurt his feelings how much criticism he got, but this industry seems to be vastly profitable and not terribly bothered by the bad press that they may have gotten. Mr. Miller, what percentage of the industry's profits went into safety research and development before this?
Well, I don't have that information with me, but I know that we have done studies on the basic R&D that the industry does and percentages into different areas, and I'll be happy to get that information back to you. I just don't have it with me.
Okay. Anyone else venture a guess on that? Okay. Any other questions? Mr. Chairman, I yield back.
Thank you very much, and I would like to recognize the chairman of the committee, Mr. Hall, for any questions.
Mr. Chairman, since like everybody up and down the row here on both sides have other things they've been doing all day today and the problems we have, I've been looking for a doctor to give me an appointment tomorrow to take my appendix out again, where I won't have to cast those bad votes tomorrow. But I haven't been able to get that. But I won't
can
take
do the
their
anesthesia.
time because I don't know what's been asked. But if I might, I'll send some questions, and I'm sure they'll answer them if you ask them to properly.
Thank you very much, Mr. Chairman. I'm just going to follow up just one very brief question before we close the meeting. I guess along the lines of what I was suggesting was, for instance, I'm going to ask Mr. Kratz and maybe Mr. Miller. You know, when you design, for instance, you showed us all the materials that you're going to put down under, 10,000 feet of water, for instance. There has to be some fairly basic research into materials that I'm sure your company doesn't do. I mean, really basic research on materials that can withstand that pressure. So along the lines, and the rank member brings up a good point. I mean, the blowout preventer appears not to have worked, but maybe it was a materials issue on what the material was, and the federal government supports a lot of materials research. Does the industry have the ability to do that? Is there, and Mr. Miller, maybe you can answer, is there something within the industry that can do that?
Well, that's a really good question. We've been working for a little while now on a new standard on high-pressure, high-temperature equipment, and in particular, we're looking at equipment that will be rated higher than the 15K, 15,000 that Mr. Kratz mentioned. And one of the real challenges for us in developing that standard is the materials section, because what we want to develop, as many of our standards are, primarily performance-based standards. So we'll set the criteria for, generally speaking, what the performance of the material must be, but not make it so specific that it excludes the innovation in industry. And so what we ask the members of the committees to do is to bring to us their broad outlines so that we can craft a standard along those lines to allow that innovation to continue to take place, as was mentioned earlier. But I can provide that information back to you and where we are on that standard and when we expect to publish it.
Thank you very much. Mr. Miller, anything else?
Well, Mr. Chairman, just because you asked questions, I think I should. Well, first of all, it's pretty clearly that blowout preventer didn't work because there was a blowout that was not prevented. So I think we can say conclusively the blowout preventer didn't work. And we can argue about why, but I don't think you can argue about whether. We've been talking about an event at 5,000 feet below, about a mile deep, below the surface, and how extreme that is, how extreme the pressures are, et cetera. And now we're talking about drilling at 10,000 feet. Is that going to double how extreme, or is it more exponential? What are the pressures going to be at 10,000 feet as compared to 5,000 feet?
I'll start. And, I think the industry is, if not prepared, has been preparing for quite a while for 10,000 feet. The Q4000, for instance, there was a lot of R&D help from tax credits on that vessel. It was the first vessel specifically designed to work in 10,000 feet of water, funded by MARAD. Since then, we are producing out in 9,000 feet. So there has been, and there continues to be, and especially with Brazil on the horizon, there's a lot of incentive for the industry to develop the capabilities in 10,000 feet of water. Most robotics now are designed for 10,000 feet of water. In fact, 10,000 feet of water is becoming pretty much of a standard basic design parameter for any service company or driller doing work in the deep water.
And one thing that I could add, Ranking Member Miller, is that as we move into some of the ultra-deep water, some of the things that we'll want to look at are the idea of what's known as a safety case approach. This was a recommendation that our Joint Industry Task Force made to the Department of Interior when we had those 30 days to respond right after the Deepwater Horizon, and it was included in the final White House report that they would consider a safety case. And what that is a more risk-based approach, so that you're looking at your actual individual well and you're combining the safety approach from both the driller and the operator to make sure that you've considered all these different risks as you've described when you move into different environments. So that's another area that you could sort of innovate on how you approach your safe operations and your compliance.
Mr. Chairman, I don't have any more questions unless you do.
No, thank you very much. I want to I want to thank the witnesses for your valuable testimony and the members for questions. Again, I want to apologize for us starting late, but I will have you out on time because your time is valuable. The members of the subcommittee, including those who weren't here today, may have additional questions for witnesses and would ask for you to respond to those in writing. The record will remain open for 2 weeks for additional comments from members. The witnesses are excused, and this hearing is now adjourned.